Hi friends, in this video let us discuss what is the basic procedure of convolution sum. Of course there are many methods to solve this convolution sum. I am following one of the methods here and I like to explain the procedure for this. So let's move forward and how this convolution sum will be solved. So we need to see the basic operation, I mean basic formulae, and these are the basic formulae. The first formula is convolution sum and it is defined as y of n is equal to sigma k equal to minus infinity to infinity x of k h of n minus k. So x of k is the input signal and h of n minus k is the shifted impulse of the discrete time system, and of course y of n is the output of the system. Okay, so now we need to define some one intermediate signal, and that signal is obviously the multiplication of w x of k h of n minus k, and that we have called as wn of k. So it's an intermediate signal, so nothing new in it, simply we need to represent the sigma part into one signal. That signal is intermediate signal. So let's see the significance of this signal also. So the output of the system is y of n is equal to sigma k equal to minus infinity to infinity wn of k. So simple. Okay, of course these for wn of k should be not normal brackets, those should be the square brackets. Okay, so please keep that point in your mind also. So that's all. So these are the formulae we need to use for the convolution sum, and let's move on to the official procedure and evaluation procedure, that is a step-by-step procedure. Let's see here. Yeah, so first graph x of k and h of n minus k as a function of variable k to determine h of n minus k. Of course reflect h of k about k equal to 0 to obtain h of minus k, and then shift h of minus k by minus n. So what does it mean? It's very simple. So for example, let me explain this part clearly. So the idea is, see, if this is a signal, this is a signal x of the signal is x of n. Of course this is discrete in nature, so it should be square brackets, and this is n, and this is h of n, like this. This is h of n and this is n. So what I need to do first, the first step is I need to represent them in terms of k. First let me change this part into k, of course this part into k, and again this one also change this part into k, this part into k. Very simple concept. Once I have done this, but I want this part as h of n minus k. So how can I deal this? So this part is very simple. If for example this is my discrete signal, signal will be the same, simply the variable is changed. But coming to this part, this is h of k. For example, this is my signal. Yeah, signal is same up to h of k, but I don't want h of k, I want h of n minus k. I want h of n minus k. So how can I do this? Okay, this part will be explained now. So please see, first let me remove some part so that it will be very easy for you to understand. Yeah, so the idea is, this is, yeah, let me clearly understand, make you understand this part. This part is very simple. Okay, let me clear everything and come back. Yeah, so as we know, x of k is very simple, simply substitute k in place of n. But for coming to h of n minus k, how this can be done? And let me show you clearly here. Yeah, this is my n and this is my h of n. For example, this value is maybe 1 at 1 and this value may be 2 at 2 maybe, or we can call it as 3 also, maybe this may be 2, like this, for example. So this is the case, and this value is 1 and this value is 2 and this value is 3. Yeah, now how to do this part is very simple. Yeah, first I need to change this variable into k, and what can I do with this? This is my, let me take this as h of k only. Yeah, how to do this with h of k? H of k means simply changing the variable, so the same thing will come here. Same thing will come here, as this is h of 3. This value is 3 and this value is 2, as we have discussed, and this is 1 and this is 2 and this is 3. But what I need, what we require, our requirement is something different, and I am requiring here h of n minus k. H of n minus k. I want this part. So how can I do this? So I want h of n minus k. First I want to get h of minus k first. Okay, according to this I want to obtain h of minus k. How can I do this? This is simply time folding operation. So let me do this part. Yeah, whatever the value at k equal to 1, that should be the value at k equal to minus 1 now. Okay, please observe the green color lines. So these are my final lines. Okay, end results. Similarly, this is 2 value minus 3. That's all, very simple. Now, yeah, now how can I deal with this? Now what is the step? And then shift h of minus k by minus n. So now I want to get this part, I want to shift this to minus n. Minus n means we need to shift this towards n units towards left. As it is minus n, I need to go towards left. So let me remove this thing, so please understand. So what will happen? Now I like to take draw this in blue color line. Final result is in blue color line. So it may be somewhere here, and this value is 2, this value is 3, and this value may be 1. Yeah, and I need to shift up to minus n. So minus n should be like this. Minus n is here. Okay, this is minus n. Of course, this is minus n. Minus n. Yeah, what will happen? Minus n minus 1. Similarly, this part is minus 1 minus 2. Yeah, now this is my signal. So now I can call, like, this signal is my h of n minus k signal. This signal is h of n minus k signal. So in this way we need to proceed. So I request everyone to please follow this part. So what we need to do, we have what we have, first point, what we have x of n and h of n, two things we have. Now what we need to do, we need to change x of n into x of k. It's very simple, simply substitute k in place of n, that's all. Coming to h of n, what we need to do, we want h of n minus k. So for this, what we need to do, first we need to convert, we need to replace n with k, then we will get h of k, and then we need to shift, we need to reflect that across k equal to 0. Then what will happen, it will be h of minus k, then we need to shift towards minus n. So that will be like this, h of n minus k. So this blue color signal is the final signal. Okay, so this is the concept we need to use. So this is the first step. So once we have cleared with this step, then we can move forward. Once this step is over, yeah, begin with the time shift n large and negative. That means As per my knowledge, so I can say that n should be large and negative. Okay, so blue color what we have done so far. So the blue color one, the large value is minus n minus 3. So from that point start we need to start shifting our signal, blue color signal. So write the formula, write the function form Wn of k. So my job is Wn of k. Okay, Wn of k. What is Wn of k? It is the multiplication of x of k h of n minus k. So yes, these two should be multiplied and Wn of k value should come. That means for Wn of k should not be 0. In any one of these two should not be 0. That means these two signals should be overlapped. So x of k is there and h of n minus k is there. Now I am starting from the last, large n negative. That means h of n minus k, I need to move towards right. And I need to see the values where these two are having values. Okay, that will be clearly explained by taking an example. Then increase the time shift n until the function form of Wn of k changes. So we need to see until it will be changed. Okay, and the value at which the change occurs defines the end of the current interval and then the new interval starts. So in this due course, okay, we want only in overlapping of these two signals, but still the equations will keep on changing for one step to some other step. For example, if h of n minus k is approaching x of k and it is having with x of k, and once it is leaving from x of k, the signal will be changed. Okay, those things will be clearly understood by taking the example, and while going to a problems we will do it. Next, the value at the end, which at which the change occurs defines the end of the current interval and then the new interval starts. Okay, that will differentiate from one interval to another interval. Let n be the new interval and repeat steps 3 and 4 until all intervals of time shifts and the corresponding mathematical representations for Wn of k are identified. So those things we need to see. So at which everything will be identified, and this usually implies increasing n to a very large positive number. So what we need to do, we need to see that the n should be very large value and n should be very large negative value to very large positive value, such that where these two signals x of k and h of n minus k will overlap, and where the signal will, where the intervals will be changed. Those things we need to catch up, and we need to do summation accordingly. Now for each interval of time shifts, sum all the values corresponding to Wn of k to obtain y of n on that interval. That's all. So once you have obtained Wn of k, what we need to do? We need to do the sigma to get y of k according to y of n according to the previous formula. So this is the explanation for the step-by-step procedure of convolution sum. So thank you so much for your careful listening, and please like this video and please share this video with your friends and family. And if you haven't subscribed to my YouTube channel, please do subscribe and kindly press the bell button so that you will get the notifications whenever I upload any video. Thank you so much.